Hello everyone. Can you please let me know, anyone, if we are live? So I'm also looking at the chat. So can anyone please let me know if we are live and like if I'm audible, if you are able to see my screen as well. So just let me know this thing, and then we'll start. Hello. Okay. Yes, it's live. Okay, great. Okay. So audible, invisible, live. Great, great. Hello. Hello, Aparna, Suryakant. Okay, great. Hello everyone. My name is Mohit. I'm instructor at product engineer at Coding Blocks, and so basically this is a session for mathematics for machine learning, right? So mathematics is like very important subject, and or if you talk about machine learning, especially, then it becomes very important because we will understand why it is very important in case of machine learning. So the prerequisite of the session is you just need to understand what machine learning is, and I hope you understand that thing, right? You know the basics of machine learning, that there are some different type of machine learning algorithms. There is something like supervised learning, there's things like unsupervised, semi-supervised, and then reinforcement. So there are these things in the machine learning. So I hope that you already know about that, the basics of machine learning, and also if like slightly there's things like computer vision and NLP, right? So there are some algorithms in machine learning. Like if I don't know how many of you have done the very core of machine learning, like at the very foundation, what machine learning actually does. But if we see at the very end, very at the very core of machine learning, it's all about statistics, probability, and mathematics, like linear algebra, probabilities, you'll say differential calculus. So this becomes like also statistics and probability are a part of mathematics, if we just very talk about very broadly mathematics, right? But like if you talk about a very specific domain, then statistics is different. Linear algebra is a very specific or very different domain. Differential calculus again a different domain, but as they all come in a mathematics part. So I hope you understand that thing. So when I'm saying that mathematics, it involve everything like statistics, probability, linear algebra, calculus as well, right? Okay. So we can basically start with a very basic example, and meanwhile, like if you have any doubt and you want to ask something related to maybe a topic or off topic, we can take some question at the end of the session. But if you have any doubt meanwhile, you can just post it on the chat. I'm looking at the chat as well, right? Okay. So I hope that everyone know this thing called linear regression. So let me just write it over here. Okay. Yeah. So there's things like linear regression, right? So regression is a kind of a, those who do not know what is linear regression, let's just pick the term regression. So regression is a part of a machine learning algorithm where you predict the continuous value. So continuous value can be predicting the prices of house. So I hope you know that there are things like continuous values, and then there are things like a discrete value. So continuous value, like predicting a house price, or then another example could be predicting a sales price, right? Sales price of the maybe the stock price, like the stock will go up and down, or what will be the price value of that particular stock on that particular day. Or maybe the things like what is the AQI, like air quality index of Delhi, maybe tomorrow or maybe month after, so on, right? These are things like where you actually predict something in a continuous value. Something like if you are predicting house price, maybe it can look like $9,999, something like that. There's no house so cheap, but maybe we can just say, or maybe there are 75 cents as well, right? So these are the continuous value. So the one particular example or a use case that we are going to see is, let's suppose you are a data scientist or machine learning engineer at Amazon, right? So what Amazon actually does, I hope everyone know that Amazon it sells something, like it distributes, like it has a lot of products, and a lot of buyers go to Amazon.com website or maybe app, and they purchase something, and then through that the Amazon get some profit. So this thing, like Amazon want to increase their revenue, or they want to predict what would be the sales, what would be the purchases of, what would be the sales in the month of December, right? Since it's a month of festival, like the Christmas there, New Year's there, and from maybe like after 10 days, 8 days, there will be New Year, and 2021 will be there. So a lot of will have some determinations to buy books, so maybe they will go in on Amazon.com and then purchase something and do things, right? So what Amazon people wants to do, let's suppose, let's just take one as use case. They want to predict the sales, the total sales, right, of this month or maybe this week. So I hope everyone know that machine learning works on the previous data, that the data that you have in the past, right? So they have to define something like the input variable and then output variable. So what would be the input variable and what would be the output? There can be a lot of input variable in this case, but I'm just talking about one input variable, that is the time spent by a user. So this is basically the time spent by a user on the shopping website, and what is the prediction, like what you have to actually predict the sales, right? The sales of user, or how much amount of product he will buy, something like that, right? So I hope everyone know that if you have to buy something from Amazon or Flipkart, what you generally do is you spend a lot of time exploring that product, right? So it will be a natural phenomenon. Like if you are spending low time, for example, you are just spending 0 hours, you will probably not buy something, or not buy a very big amount, right? So the sales of users will not, the sales of the product or the sales of the Amazon.com will not be very high. So let's say the sales is just maybe like $1 million, something like this. And for example, if there's all the users, like all the users combinedly spend somewhere around maybe 10 hours, right? And at that time the sales will definitely go up, and maybe it could be like $12 million. So similarly, there will be a lot of data that the Amazon.com have already collected, because it is the duty of data scientists, or maybe those who are working on the data analysis part, or collecting the data is also part of machine learning and data science, right? So basically you have to collect this data if you are working on that domain. But let's just talk, we are going to talk about the mathematics. So this is not our responsibility to collect the data. So let's just suppose we get the data by the users, or the engineers from the Amazon, right? So let's suppose these are a few data points that we have. So if users spend 8 hours, then maybe the sales will go up to $10 million. And if you just spend 2 hours, maybe the sales is like $3. And there can be more data points. So these are just data points. These are like first data point, second data point, third data point. There can be like 1,000 data points. There can be 1,000 such data points. And since Amazon is like very big website or big company, so definitely they will have a lot of data points. They will have a lot of very huge data, right? So this is the X is basically the input data. Y is your output data, and this is whole commonly known as the supervised algorithm, supervised machine learning algorithm. And the algorithm that we are going to talk about is known as linear regression. Regression because we want to predict the continuous value, and why linear? Because it will be linear in nature. So linear and non-linear, if you have studied the class 11th mathematics, you know that this is linear, this is not linear, right? This is not, let's say this is non-linear. So there are some non-linear model in machine learning as well. And the one that we are going to talk about is just a simple linear model. Okay. So yeah, so the first step is basically you what you generally do is, as a machine learning or a data scientist, you try to plot your data, right? Something like known as data visualization. So let's do the small data visualization. On the x-axis, let's say you plot the time spent by users. Fine, this is the time spent by user. And on the y-axis, let's say you just plot the sales of Amazon in maybe weekly or daily or monthly, whatever the scale could be. It could be anything, right? Fine. Then like if you plot this thing, like if you have zero sale, like 0.1, you can just write 0.1. It is fine, right? zero में तो it doesn't matter, right? Zero में कैसे ही sale होगी if you're not visiting Amazon.com. So let's say 0.1. So 0.1, this is just 1 hour, so maybe this point will lie somewhere here. Then if you just if you spend 10 hours, then this will be 10, and then 12 will be over here, so it will look somewhere here. So I'm just plotting it rough, not exactly plotting the scale values, but I hope you can do that if you know how to plot a simple graph. Let's say there are a lot of points like this, right? Definitely it will look like this. Why? Because it will have a positive correlation with the time. The sales will have a positive correlation with the time. What is positive correlation? It means if you spend more time on Amazon, the sales of the Amazon.com will definitely go high, right? There will be some points, there will be some times that when users spend a lot of time on Amazon.com, but the sales is still not very high, because let's say some people do not want to purchase, they just want to explore, they have very free time and they want to explore just Amazon.com to just compare the prices of different things, right? So there can be a lot of cases. There can be things like बहुत ज़्यादा outliers भी हो सकते हैं. So these are known as basically outliers. So let's not talk about them. Let's just talk about a very basic data that we have, something like this. A normal trend, if you spend more time, you will get the more sales, right? Now, what is the idea or how you want to predict sales? For example, let's suppose in the month of January, let's say the time spent by user is somewhere around maybe 7 hours or maybe 5 hours, right? So you want to predict for that value. So how will you try to predict? So basically what you need to do is linear regression. So I hope everyone know what is the equation of a line. So line equation is something like this. Y is equal to mx plus c, right? Fine. This is the equation of a line. Generally in what is y? Y here is your let's say your sales. Fine. What is your x? X is your time spent. What are your m and c? These are your parameter of any algorithm. So there are a lot of algorithms in machine learning, and these are the parameter that you have to learn. Right now you do not know what are the parameter, what will be the value of these parameter, but through machine learning, through writing an algorithm, through writing this linear regression algorithm, we have to find, the goal is to find m and c. You need to get this m and c from somewhere. Why you need to get m and c? Let's just say, I hope that everyone know how to how a line look like. So maybe this is a line, right? This is one line. Similarly, this is another line. Fine. This is another line. So there can be a lot of line in the space. So this is a space like 2D space, and in 2D space you can plot multiple different lines. So these are just 3 lines that we have plotted, let's just say, right? And yeah. So basically I want to ask you one thing, like if you are there, if you can chat. So let's say this white line is the first line, this blue line is the second line, green line is the third line. Which line actually represent this data in a very best way? Like they all represent the data, but which line, which of these lines actually represent this data with minimum error? Can anyone? Blue. Okay, Jess said blue. That's absolutely right. Because why do we say that blue? Because blue is more close to the data points, and Suryakant and Anushka also said blue. Right, correct. Everyone said blue, and the second line, that is the correct. So blue line is the most appropriate one, because so there is a reason for that as well. Although like for you this is appearing that yes, this line is passing through a lot of points, and yeah, this line will be the best fitted line. But for machine learning you cannot say that, oh, this is going through a lot of points, that's why it's best. Machine only understand numbers. If can you compare line number 1, line number 2, line number 3 with terms of some numbers? Can you say that this has a very bad score and this has a good score, this has a even more worse score? So that's where we introduce a new term known as error function. Error function, or sometimes it is also known as loss function as well. Loss function, right? So error function or loss function, whatever you want to call, in all the machine learning algorithms, there is this term called error function, loss function. And just one more thing I want to show or tell that in machine learning terms, generally this line equation does not, we do not represent it in a format of M and C. We generally write y is equal to theta naught plus theta 1 x, right? So this is the equation. This is theta naught, theta 0 you can say, right? This is the equation that we generally use in terms of machine learning. And this is exactly same as a line. This is again an equation of a line. Why? Because it's right now, this is c equal to theta naught, e is equal to theta naught, and m is equal to theta 1. So I have just renamed these two terms, right? M ko I have just said theta 1, and C ko I have just said theta naught, and I hope this is fine, right? There's no issue with that. You can change the variable names. It's okay. So why this line equation is important? For example, let's suppose you know the thetas, theta naught and theta 1 of this blue line. Definitely blue line, white line, green line, these three lines will have some theta value like theta naught and theta 1, right? All these three lines will have some intercept and coefficients, correct, right? But we have to find what are the coefficient of this blue line. That is very, very important. What are the coefficients or what are the thetas of this blue line? That is very, very important. Why? Because if you have thetas of this blue line, then it is very easy for you to predict in the future. Why? Because let's suppose you have theta's value for this blue line, and I'm just assuming that blue line will have theta somewhere like for theta naught it is just 1, and for theta 1 let's say it is 0.5. If you have this equation, what can you simply do? Let's suppose a new for a new month like January month, there's a number of time like user spent time is actually 5 hours. You can just simply put 5, x is equal to 5 in this equation, and you will get the y value, right? So that is very easy part. So what you need to do is you need to find these theta value, and that is the most important task. So the whole goal of this regression technique or this linear regression model or machine learning model is to learn these theta's value. Particularly we are talking about linear regression. Why it is linear? Because this line will be a linear, right? I hope line is, everyone know that line is a linear thing, right? If you talk about parabola, this is not a linear, but line is a linear, plane is a linear, hyperplane is a linear, right? Okay, so we are talking about line, we are just talking about line only. So you need to find these theta's value, and that is most important. But first we need to understand na कि कौन सी line के लिए which line has less error. By just by looking at hello Abhay, just by looking at these line, we know that blue line has less error, but we need to prove it mathematically, right? So for that, let's again draw few point. I'm not drawing all the point, but let's just draw few points. Okay, I've just drawn only 4 points, and let's say that this is your current line. I'm just taking it assumption that this is your current line, high above. Okay, right? So what it actually means is this is your time spent. This is your x-axis, time spent, and the y-axis is your sales, right? Y-axis is your sales. Now what will happen, like if I give input as this value, let's suppose this x value is anything, like x value is x, anything, like it can be 7, 5, 8, 10, what, depending on the scale. If I give x value input in this line, what will I get output? I will get output as this value, right? This will be the output if I give input as this x. What will be the output if I give this x2? Let's suppose this one. If I give this x2 as input in this line equation, then the output will be this one, right? This value. So let's say this is y1, this is y2. Fine, right? Okay, so let's suppose now if I give input as this one, let's say this x3, the output will be over here, right? I'm just erasing this part because I do not need these lines. Fine. Okay, so I was just saying that if I give input as this x1, let's call it as x1 now. If I give x1 as input, this value, what will be the output I'll get this value as an output, and this will be the y1. But what was the actual output of this input x1? The actual output was this value. So as you can see, this point is the actual output, and this is known as y value or the output value. So what is the difference between our error, and we have predicted this value and the actual was this. So what is the difference? This part is actually your difference, right? So this is your difference. So you can simply write, so y hat, this is your prediction. Y hat is your prediction. So whenever I write y hat, it means your prediction. And then you'll simply do y hat minus y. Y is your actual output, right? Actual values of this input. Like if you give x1, you will get this value, but you are getting through your line, you are getting this value. So this is y hat. Y hat is your predicted, and y is simple. Y is your actual label. So you need to subtract this, and similarly you need to go for all the point. Like for x2, this is the x2 point. The output, actual output should be this, but you are predicting this. So there's a small error, very little error for this point. That is fine. And maybe let's change x3 slightly. So let's say x3 is over here. So for x3, if you give x3 as input, you will get output as this point. This is your y hat 3 or the y hat, but actually is this one. So this is the error that you get. And for the x4, this is the error that you will get. Now what you will do, you'll simply add all these error, right? You simply add all these error. You will say from I goes from 1 to m. What is m? M is your total number of example. Right now I have 4 example, total example. Right now I have 4 example, but in case of Amazon data set, you can have 1,000 examples or 10,000 example or 100,000 example. You can have a lot of examples, right? So this is what you have to do. But sometimes what we actually do is, देखो अभी क्या होगा, so this will be some negative error, this will be a positive error, this will be negative error, this will be negative error, this will be positive error. I hope you know that why this will be positive, because this is your prediction. The top part is prediction and the lower part is your actual value. So if you subtract something high minus low, you will get, so this is high minus low, you will get positive, right? For example, 5 minus 3, 2, which is positive. But in this case, in the case of x4, in the case of x4, this is your prediction. So prediction is 3 and your actual value is 5. So if you write 3 minus 5, you will get minus 2. So if you add these values as it is, what they do, they will cancel out each other. So I do not want to cancel out these error value. Instead, these error value should add up. So one thing is, either I can take a mod, right? So सबको पता है mod क्या होता है? One way is you can take the mod value. Like जो भी negative में, you just add it, you just convert it to positive and then simply add. But generally we do not use mod right now in this case. Maybe I'll tell you the reason bit later. So what you simply do is you do the squaring of it, right? So you will simply do the squaring. So take square, right. Vidyarth has said the right answer. You simply take the square. So square will also give you the correct answer or the correct formula. And this is actually known as your loss function. Or you simply write this is your loss function. And sometimes you generally you take the mean value. So what you do is you add everything up and you divide by 1 by 2m. So it's 1 by, either you can divide by 1 by m or 1 by 2m, that is fine, because it's okay, right? So you just simply do 1 by m, and this is your loss function. So I hope everyone know by now that how we got the loss function. So what this loss function actually says, what it actually tells, it will give you basically a real number. First thing is, it will give you a real number. Yeah, it will give you a real number, fine. And what does that real number actually tell? That real number will tell you how much loss or how bad this line is. So if any line has a zero loss, that line is a perfect line. And when this can happen, that any line will have a zero loss, when this can happen, when your data is something like this, and your line and the line that you're talking about will look like this. then you will have a loss of 0. Because if you talk about now x1, x2, x3, x4, x5, all the points are actually lying on the same line, right? So your prediction value and your output value will be the same, right? So in that case, in this case, the loss value will be 0. But for example, if your data is like this, and you have a line something like this, let's say you have a line like this, definitely this will not have a loss value of 0. This will have a loss value of very high. Let's say this is, you will add this part, this part, this part, this part, this part. So these are the loss values for each individual elements, or you can say each individual maybe data point, right? So that's why when we said that, when you said, when in fact you said that the blue line is the best line. So how can you prove that blue line is the best line? Because if you take the loss value of each data point and you do the squaring and you do the addition and you take the mean, then the overall the loss function or the loss value of the blue line will be very less as compared to the loss value of one line or the three line. So I hope this is visually you understand that why this happens, but more mathematically we have proven this, right? So we have used this loss function and it will be like y of I and y hat of I and y of I. So this is known as mean squared error, MSE, known as mean squared error, right? So this is the loss function that we have for a linear regression. Now the ultimate goal of the linear regression or the machine learning or the current algorithm is to find theta naught and theta 1, right? So always remember, what is the ultimate goal of linear regression? So let's also give a title here over here, linear regression. Okay, so what is the ultimate goal of the linear regression over here right now is to find the values of theta naught and theta 1. And we cannot simply write, we cannot simply say that I want theta naught and theta 1. I need to form something, I need to form some loss function. And then I said that I have to find those, I have to find that line that will have minimum loss function. Now my goal is changed. So the goal is still that same thing, but I have formulated in a different way. Now my goal is to minimize the loss function, right? To minimize the loss function. So this is my goal. Now what will happen if you minimize the loss function? If you minimize the loss function, you will get the blue line, a line which is more close to blue line, right? It will be more like a blue line, not a blue white line or not a green line, right? It will be more like a blue line. So if you have a line which is more like a blue line, you will have the best thetas. You will have the perfect thetas for theta naught and theta 1, and that and then your goal will be satisfied. It means you have achieved the goal, right? So so I can say I have formulated in a different way. Now my task is to minimize the loss function. And what is the loss function? So loss function is known as mean squared error. Loss function or error function, both are same thing. So the loss function is 1 over m, like 1 by m, to take the average summation I goes from 1 to m. Why from 1 to m? Because I want to do for all the data point. Like I have 1 data point, 2 data point, 3 data point, 4 data point, 10 data point, 100 data point, all the data points. And what you want to do in that data point, I will calculate the y hat. Now what is y hat? Y hat is the prediction of that point, of that input x, from that line, from this line, for maybe this line, this line, this line, this line, any line. And then you'll subtract the actual label, you subtract the actual output, and then you'll do the squaring. So you have to do this is your loss function. You have to do this for all the data point, and this will become your loss value. So you have to minimize this loss value. And okay, so one more thing, everyone can see the square over here, right? Everyone can see the square. Now I hope that you know that what is the graph of y is equal to x square. It looks something like this, parabola. Correct. It looks like a parabola. Okay. What is the loss? What is the graph of x minus 5 whole square. It will look again like a parabola, but it will have some changes in the axis. Now it will be over this point. Earlier it was 0, where the minimum value of the loss function, and on the x-axis it was 0. Now this graph is shifted 5 units to the right of the, you can say, the axis or the plane, right? And again you see, what is our loss function? Loss function is something of squaring. So if you do something of squaring, you will get the value, the graph of something like parabola. So the loss function that you have, it will look like a parabola only, right? But on the x-axis you will have theta value, so something like theta naught or maybe theta 1, right? And on the y-axis what you will have, the loss function, which is j. J is the loss function, as you can see, right? I have written j. So on the y-axis you will have j, or the loss value, and on the x-axis you will have theta value. So what it actually signifying is, if you keep theta value as something like 0 or maybe 1 or maybe 2 or maybe 3 or maybe 4, you will have a very high loss. Similarly, if you keep theta value as very high, something like 1000 or 2000, you will have again loss value as very high. But if you keep very optimum theta value, I do not know what this theta value would be. Let's call it as theta opt, theta optimum, right? Let's call it theta optimum. But if you keep this value of the theta, what will happen? The loss value will be minimum, and this is that theta you need to find. So you need to find that optimum theta where the loss value will be minimum. And I hope now you got that why this loss function is of the graph of this graph is looking like a parabola, because it has a square on the top, right? The square and the square always create or form a parabola, right? But how do I get this optimum theta? I do not know where this theta would be. I just have this loss function. That's it. I only have this loss function. J is equal to 1 over m sigma. So it's sigma I goes from 1 to m, and y hat I minus yi square. I just have this loss function. How will I find the optimum theta value? Anyone know the answer? How to find the minimum value of any function? I would put it this way. For example, let's suppose I have this function y is equal to x minus 5 whole square, and you have to find the minimum value. At which point this function will be minimum? Something like argument of x minus 5 whole square. So what you need to find is, okay, so someone has said first derivative test differentiation. Yes, so the idea is correct. You need to take the differentiation, and what does the differentiation actually does? It will take the derivative, right? It will take the derivative, and you just need to put it equal to 0, and you will get the minimum value, right? So if you do x minus 5 derivative, x minus 5 whole square derivative with respect to x, what you will get is, okay, so what you will get is so something like x minus 5 equal to 0, and then you will have x value as 5, right? I have directly differentiated it. I just assume that you know how to do the normal differentiation, right? So it will be x minus 5 equal to 0. Basically it will also have 2, but the 2 will go in the divide and it will become 0. So x minus 5 is equal to 0 and x will be 5. So at this point the function will be minimum. And if you want to find the minimum value of the function, so this is the point, this is that point or that location where you have the minimum value, not what is the minimum value of the function. And if you really want to find the minimum value of the function, you simply put this x value over here, right? Now the same thing you have to do in your loss function or in your linear regression case. So what you need to do is, you have this loss function j, fine. You need to take the derivative, you will, and put equal to 0. you will get values of the thetas. Right now you cannot see thetas, but again you will see the values of thetas, because this j is a function of theta. J is a function of theta, because if you try to change your theta naught and theta 1, if you try to change your theta values, if you try to change your theta's value, what will happen? Your line will differ, right? You can see now, if you change the theta's value, line 1 have different theta, line 2 has different theta, line 3 are different thetas, line 4 will have different theta. Like, let's create a line 4 as well. Where is, yeah, let's create a line 4 as well. So let's say this is the line 4, it has different thetas, right? So all line has different theta. So if you create different, if you have different thetas, you have different line. If you have different line, it means you have different loss function. If you have different loss function, it means the loss function is actually a function this function is actually a function of theta's value, right? So that's what I was proving, that this loss function is a function of theta values. Now, before that, before doing the derivation and all these things, there's a very important algorithm in machine learning, and I hope you have heard about that algorithm. I don't know if you know, but you must have heard about that if you know the machine learning. So that algorithm is known as gradient descent. So it's called as a gradient descent, right? So we'll talk about the gradient descent algorithm. So what it actually does is, this algorithm is used to minimize any function or to maximize any function or to optimize any function. So I can say that this algorithm or this formula or this way, the gradient descent way or the gradient descent algorithm, is the optimization algorithm. So optimization algorithm, right? So you give any loss function and you say that I want to minimize it. You can use gradient descent to minimize it. So we will talk about the gradient descent. So optimization technique. So it is an optimization technique, right? Okay. So right. So let's do this now. Okay, so let's try to talk about let's talk about gradient descent, or how it actually minimize any loss function and how this will help us to achieve our goal, right? So this is important. So let's understand that how this will help us. Okay, so this algorithm has few steps. So the first step is that this is lagging somewhere, right? I'm not able to write it properly. Let me do something. Okay. Yeah. So okay. So the first step is you need to initialize. So you can say the first step is to initialize, or let's call it randomly initialize the theta values. The theta values. You can randomly say that theta naught will be anything and theta 1 will be anything. Like randomly, I hope you understand what is random. Anything, like you can give any value. You want to give 0 value, just give it 0. You want to give 0.1, you can give 0.1. You want to give -1, you can give -1 as well. So in the first step, you simply need to initialize theta values as random. Anything, fine. Now the second step is, so this is the most important step. So the second step, it look like you need to repeat until convergence. So you need to repeat this step until convergence. You will simply repeat simply the second step until convergence. And what is the second step? So it is basically theta naught and similarly theta 1 is equal to theta 1 minus alpha del j over del theta 1. So these are the two equations that we need to follow. So okay, so let's revise it again. So what is gradient descent? It is an optimization algorithm or optimization technique. For example, if I say that I want to minimize any loss function or any function, let's not call it loss function. Let's say I want to minimize any function. I can use it. I can use gradient descent algorithm to minimize or to optimize that function, right? So how this gradient descent actually works? The first step is you initialize those random values, like you initialize the theta's values randomly, anything, right? The second step is you need to repeat these two equation again and again until you converge. So what are these equation? So these are known as update equation or update equation, right? These are known as update equation. So what are the update equation? It is theta naught is equal to theta naught minus alpha, and you multiply by del j over del theta naught. So this is actually the partial differentiation of the loss function with respect to theta naught, right? So partial differentiation सबको पता है, थोड़ा थोड़ा idea है, right? What is it? What is this? This is the partial differentiation of the loss function j with respect to theta 1. Now, why I'm taking the partial differentiation? Anyone know why I'm taking the del and not the d? dj by d theta naught. I'm not taking that thing. I'm saying del j. So del is like the partial differentiation. Anyone know why we are taking the del? So, okay, if you do not know, you just need to understand when you take the differentiation, a normal differentiation, and when you take a partial differentiation. Maybe you can just Google it, and although you already have studied this in your class 11th and 12th, sorry. So while doing the calculus and all these things, right? So, but the in a very crux, in a very nutshell, it's just that you generally take partial differentiation when you have a lot of variables, lot of different values that can vary, and you just simply take the differentiation when you have only one value in your function. For example, if I say y is equal to x square, if I have to take the differentiation, I'll simply say normal differentiation, not the partial, right? We use partial differentiation when there are more than one independent variable. That's correct, Vidyarth. Correct. And when, let's suppose you have a function which is y is equal to x square z plus z square x, and here x and z both are independent variable, not the constant. Don't think that z is a constant. If z would have been the constant, you simply again take the derivative. It's normal differentiation, right? Not the partial one. So when you take the partial differentiation, when you have the two different variable, and right now in our case we have two different variable. I hope do you know what are those two different variables? So one is theta naught and second one is theta 1. So we have two different variable. That's why we take the partial differentiation and not just the normal differentiation. Okay, so let's move forward. Do we need to go into the details of how to take the differentiation of the loss function or any function? Maybe if I just simply write what is the differentiation of this function, if you're not able to understand, then let me know. Otherwise, let's just see, right? So if I say I need to find a partial differentiation of, so this is the j value, right? This is the loss function. Loss function is 1 over m summation, okay. Let's write summation, okay. Right, summation. Right, so summation I goes from 1 to m, and it will be y hat I. So here you just have to write y hat I. So something like y, okay, I'll just simply say y hat I minus y of I, right? And this is the square, right? This is a square. So this is the loss function, and you need to take the partial differentiation of j with respect to theta naught. Now you cannot see theta naught anywhere. Right now you're not seeing any theta naught in any of this whole function. But this y hat I, this is not y hat. The y hat is just a normal term. What is y hat? Y hat is your theta naught plus theta 1 x. So maybe you can just simply write theta naught and theta 1 x in case of in place of this y hat I. So your loss function will look something like this: 1 over m summation I goes from 1 to m, and then you will have theta naught plus theta 1 xi minus yi square, right? Yi square. And now if you want to take the differentiation, if you want to take the differentiation with respect to theta naught, I hope now you are able to do, right? So these are the constant terms, so they will come out. So maybe they will come out, so it will be out. So del j over del theta naught, it will be 1 over m summation I goes from 1 to m, it will be out. Now do we have so this is basically a square first, right? So you just simply write 2 and the whole term as it is, so it will be theta naught plus theta 1 x I minus y I, and now you use the chain rule, right? So this is basically, first you will derivative, you will take the derivative of this whole function, since it is a square, so it's something like z square, it's something like z square. You will take the derivative with respect to z first, and now what is z? Z is this value, this whole value is z. Now you take the z with respect to z, right? Let's just यहाँ पे theta आ जाएगा, right? Now you take the derivative of this theta naught, theta 1x minus yi with respect to theta naught. So it will look something like derivative of theta naught is just 1. Okay, the derivative of theta 1x is 0. Why? Because there is no theta naught in this, so this will cancel out. And what will be the derivative of yi with respect to theta naught? Again it will be 0. Why? Because there is no theta naught. So if I say something like this, what is the derivative of 5 with respect to x? Can you see 5? Oh, can you see x in this equation or in this function? No, right? That's why the derivative of 5 is 0, but there is no change. 5 is just a constant value for x. There is no change. That's why it's a constant, and the derivative of this will be 0. Similarly, if you ask what is the derivative of delta theta naught plus theta 1x minus y with respect to theta naught, you can only see that theta is in this term and not in theta 1x and y. So these two terms will be 0, and now if you take the derivative of theta naught, it will be just simply 1, right? So what is the derivative that you got? So the derivative of del j with respect to del theta m, it will be so maybe I'll write somewhere else. So over here, let's write del j over del theta naught, it will be, or maybe like let's write over here, it will be equal to 1 over m. As you can see from here, this part, this is the value that we need to write, right? 1 over m, and maybe let's also write 2 outside. So 2 over m summation I goes from 1 to m. Now again, if you see this term is again a y hat, right? Because what is y hat? Y hat is theta naught plus theta 1x, and this is the same thing, theta naught plus theta 1x. So again you will write y hat I minus yi and into 1. So you just simply multiply by 1 over here, fine. So this is the derivative of del j divided by del theta naught. Now if you talk about what is the derivative of del j with respect to del theta 1, there will be only one change in the whole equation. When you are taking the differentiation of theta naught, this equation, this one, theta naught plus theta naught plus theta 1 xi minus yi, you are taking with respect to theta naught, right? Maybe I'll just let me just do this. Just a second. Fine. Okay, you are doing with respect to theta naught, but now okay, Vidyarth has got the answer, right? But now you will take the differential with respect to theta 1, and now you can see that this term does not have theta 1, so it will be 0. This term does not have theta 1, it will be 0. What will be the derivative of this term when you take the differentiation in respect to theta 1? So it will be just xi. So it's something like this. Dekho, what is the differentiation of 5x when you take the with respect to x? It will be 5, right? It will be 5 because 5 is a constant and 5 is the coefficient of x. Similarly, what will be the derivative of theta 1 xi with respect to theta 1? So it will be just simply xi. So this equation will be 2 over m summation I goes from 1 to m y hat I, everything will be same. Everything will be same except you just multiply by xi over here. This is the only change that will be there in del j with respect to del theta 1, right? So this is the only thing that will be there. So like if you want to take the screenshot of this derivations, you can take the, otherwise I'll just simply erase it because it's not the permanent written on the notebook. So I've just noted it on the screen. So maybe like if you want to take, you can take the screenshot. Fine. So these are the two important equations that I wanted to find, right? The derivative of loss function with respect to theta naught and the derivative of loss function with respect to theta 1. These are the two important equations that I wanted to find, and through the derivation I found these are the two equations are there, right? So what I did is I took the derivative of the loss function in the direction of theta 1, theta naught first, and in the direction of theta 1 then. So these are the equations. Okay, so okay, I'm erasing this these derivations, and now I have, so I'll just simply erase this part. I'll simply erase this part. I do not need this thing. Fine. Okay. So fine. I got these equations. So I'll just simply write now what is the updation rule. It will be theta naught is equal to theta naught minus alpha. Alpha, we will talk about alpha. What is alpha? Fine. What is the value? What was the value of this? So it was 1 over m or 2 over m, you can say. But 2 is constant and it can be compensated with the alpha value, because alpha is a constant, 2 is a constant. So constant into constant or constant plus constant, constant divide constant is again a constant. So you can compensate with alpha, but let's write 2 by m. Sigma I goes from 1 to m, right? And 1 to m, y hat I, so it's y hat I minus y of I, and into 1 in case of theta naught. And when you write this thing, it will be 2 by m summation I goes from 1 to m y hat I minus y of I into xi. So this is the only term that is being added. So the whole equation will be, you just put the value of this del j over del theta naught as this equation, and you just write del j over del theta 1 is this equation. And let's talk about what is alpha. So alpha is known as learning rate. So this is known as learning rate. So this is known as learning rate. What this actually means? This means you will take a next step, and this is basically a constant value. This is a constant value. This is generally a constant value, and it actually means you take how long the step will be. So maybe we can just look at example and how this learning rate or how this whole updation equation actually works. So let's talk about a very basic example, which is y is equal to x minus 5 whole square, right? So this is the loss function. This is how loss function look like. Now you need to find the value of you need to actually find the value of x as 5, right? This is the optimum value. Right now, let's suppose I do not know this x is equal to 5 will be the optimum value, but I want to find the minimum value of I want to find the value of x where this function will be minimum. So something like argmin of x where x minus 5 will be the minimum. So not the minimum value of the function, but where at what point this function will be minimum. So what gradient descent actually does, what it says that first you need to initialize the variable, initialize randomly the variable. So what is the variable in my case? In my case, variable is, let's say, x, or you can say theta. Right now it is x, but you can also say theta. So maybe let's call it theta, or यहाँ पर भी हम theta लिख लेते हैं. So let's just write theta. Let's write theta over here as well, and let's write theta, right? So randomly initialize variable theta. So how do you want to initialize randomly? So do you want 0? Do you want 1? Do you want 2, 3, 4, minus 1, 5, 10, 15, 20? You can use anything. Let's say I have initialized over here. Let's say my theta is 1. I've said my theta is equal to 1. Fine. Because you can randomly initialize, you can do. Okay. Now the second step will be, I'll simply say theta is equal to theta minus alpha del j, this time it will not be del j, but so simply dj by d theta. And what is the derivative of this loss function? So the loss function is something like this, and if you take the derivative, it will be 2 theta minus 5 equal to 0. So it will be okay, not equal to 0, so it will be just 2 theta minus 5, right? So this will be a derivative. Now you simply need to put the value of theta. So what is the theta value right now? Theta value is 1, right? So you will put the value of 1 over here, and it will be 2 1 minus 5, which is minus 4 and minus 8. So the value of del j over del theta, it become minus 8. Fine. And now I said that what is this alpha? This alpha is known as learning rate. I've already said that, right? Learning rate. And this is a constant value. This is a constant value, and it's always positive. So it is a very small value, something like how much step you will take. So it's step like, let's say 0.1. Fine. Let's say 0.1. So if you multiply 8 with 0.1, what you will get? You will get 0.8, right? You will get 0.8 and minus. So this minus and minus will become plus. So what will happen? This will be, the new theta will be the old theta is 1. So 1 plus, because minus minus will become plus 0.8. So the new theta will become 1.8. So your new theta will come from 1 to 1.8, right? 1.8. As now you can see that you are moving towards the minima point. You are moving towards the optimum value. So now you have theta value as 1.8, and again you will do the same iteration, because the second step was repeat until convergence. So you need to simply repeat this statement until you get the minimum value, which is 0, right? Minimum value, which is 5, because at that point you will not update anything, because the whole algorithm will not update anything. It will simply understand now, like for example 2. At that point, let's suppose at any point you reach 5, x is equal to 5. What will be the value? X is equal to 5. 5 minus 5 is 0. So you will not update anything. So this part will completely become 0, right? Alpha into, since del j over del theta, it is 0, right? Because 2 into 5 minus 5 is 0. So your new theta is equal to your old theta. So at this point, when you reach at this point, you will not have some updation, you will not have any updation, and then you can simply say that yes, you got the minimum value, or you got the optimum value. And once you got the optimum value, let's say theta is equal to 5, now you have the equation of a line. And now since you have the equation of a line, what you can do, you can simply predict for the future. Let's suppose this was a line where the theta naught is equal to 1 and theta 1 is equal to 2. So what is the equation of a line? It will be 1 plus 2x. And what is the x? X was, if you remember, x was the how much time users have spent on the Amazon.com. So if you have x value, let's say the user has spent 7 hours. So what is the value you will get? You will get $15 million prediction. So this is how linear regression actually works. So I know that this is slightly complex than what we think of a machine learning because since machine learning is not a magic, it cannot do everything on its own. You actually have to tell how machines should actually learn. So these are the few things that are very, very important in terms of machine learning, because they actually learn from mathematics. And in mathematics, statistics, probability, linear algebra, because machines, again, if you talk about, let's take another example. If you talk about text data, can computer understand text? Can computer understand English? No. Computer can only understand numbers, and not even numbers, just the binary, right? Binary like 101010. I hope you know that computer can only understand binaries. And even not even binary, computer can only understand the electric signals. Like computer is electronic machine, we read this definition, right? So if the electric signal is high, the voltage is high, we say that this is 1. If the voltage is low, we say that is 0, right? So at the very core of computer, there is just, or very core of the machines, there is just number 0 and 1. So if there are just numbers, you cannot skip mathematics, because again you have numbers, you have mathematics, numbers, interchangeable thing, right? So that's why it's very, very important. And on this day of mathematics, National Mathematics Day, it's very important to understand that why mathematics is important in growing fields like AI, machine learning, data science, right? or computer vision, natural language processing. All these things are just they have the power of mathematics and statistics and probability, right? So these are the things like there are some statisticians, they like who are wonder to these fields like data science and machine learning. So maybe like if you have a very good grasp in statistics and of these fields like linear algebra, because at the very core again you have some vectors, you do the vector multiplication, you do the vector addition, you do take you by taking the transpose of a vector, you do things like this, right? So I hope you got the idea of what linear regression actually means, and how this linear regression works under the hood. So this was just a small session to encourage you, not to discourage you, like, by looking at the mathematics of under algorithms of machine learning. But these are the things that we have already seen, that these are we have already done in our class 11th and 12th. So they are only the foundation. If you know the mathematics, like basic mathematics of class 11 and 12, you are good to go with the machine learning, right? So these are the things, and these are the real applications of machine learning. These are the real application of mathematics where we actually use these things in the real world. So yes, these are the things that a lot of companies, big companies use. So you have seen like self-driven car. They're not anything magic. They are just the application of machine learning. Or and what is machine learning? The application of mathematics and statistics and these things, right? So yep. So this was a introduction session, and if you have any doubt, just let me know in the chat box. Uh, Otherwise, if you have maybe any other doubt later on, you can simply contact me on my email ID, or let me just see if there is a email ID on the description box. Okay, so I'll just simply put my email ID on the chat. Oh, fine. Okay, I'll write it over here. So or maybe you can connect or send doubts on LinkedIn. So that is perfectly fine. You can sort of discuss some of the projects if you want to do, right? So let me know if you have any doubts right now in the chat box. I'm maybe like we can give 2 to 5 minutes more, and then we can end the session. And I hope you liked the implementation and the real application of mathematics as well. So important thing, like the math is important. So you just take any subject, math is important. So I hope you do not run away from the maths, but run towards math. Okay, great. So anything that you want to add on, maybe. So let me just see. Let's wait for 2 more minutes if there are any other doubts or things they want to share. Okay, so I guess there are no doubt then, and fine. Then we can. Thank you very much for attending the session, and do let me know if your feedback, like you can share on the Google form, and let me know if you want to send a message or a mail, and we can discuss things like if you wanted. Yeah. Okay, so great, and continue learning mathematics, continue learning machine learning, and more stuffs like that. So thank you very much. So I'll end the session now, and we'll see you in some other sessions, maybe in near future, regarding machine learning, AI, data science, and all. Okay. So great, and thank you.